I was asked to add robots to this when we did the first part. So I've called this robots, Cobots, and 3D printing. And just a touch of history on this. When we started talking about robots, there were really two kinds. There were what we call Cartesian robots, which really was factory automation. And then you had the R2D2 kind of robot and articulated arm robots. And I'm not going to show those. You've seen them, the big long arms in the automotive plants, picking up cars and setting them down, putting doors on or whatever else. We have videos to show, but I don't think we have time to do it. We can come back if you want, but you're familiar with the articulated arm. Since then, there's been a naming of the activity, factory automation activity, is 3D printing. And everything that's automated today is 3D printing or 4D printing or 5D printing. And it's really all factory automation. And I'm not sure that I can tell anybody where a robot starts and where it ends. Cobots are really aids to the worker. And I couldn't find one, but the one that I would have loved to have had when I was college age, I worked in a body shop working on cars, and there's not a body man around whose knees are not shot. It's just part of, you considered it part of the trade. But today, you would wear a brace that was automatic, would take all the weight off your knee. That would be a cobot. So you will see in the factories and in many other places where there's a robotic piece of equipment working side by side with a human to make their job easier, whether that's a worker squatting in an automotive plant, putting parts in a car, or whether it's some other job out in the field, wherever. And they are very similar to the equipment that is used in medical, where they are supporting people who have either an absence of limbs or failed limbs. Let's take a look at the video on medical care. Any questions on that?
Yeah. How good was his prediction about the market?
The market is booming, and we will get to that in a bit. But medical is a very strong portion, and there are some very interesting things going on.
He said $1 billion by 2019.
Well, I don't know what. I don't know what the dollar numbers are. That I can't tell you. I can find out. I gave some in the last, in the first part of the talk, some numbers, but they were for the industry and not specifically for medical. Um, the I think we'll move on to the next slide. Yeah, as we've discussed, there's four legs to this business. One's the equipment. That's pretty mature. Whether you're talking Cartesian robots or extended arms or any part of automation, the components are don't look a lot different than they did 20 or 30 years ago. The software, however, is tremendously advanced and getting more advanced in all segments or areas of the software. Material science to me is the key to the future. They're learning how to deal with human cells, and they've got a challenge on fusing layers together. They've got a challenge on molecular structure, but they've come so far and they're doing such great work. The applications are in their infancy. They're finding more and more things to do with it and use it for. Next slide. Can I advance that myself? Or anyway, the key components on the software is the ability to take X-rays and CAT scans and convert them into files, the ability to reverse engineer, the processing data, handling material, handling orders, going from a concept to a working diagram in no time at all. That happened just recently, and I'll talk about it at the end of the talk, but that happened with COVID-19, and we found that we needed various items, face shields and other all the safety components. And every 3D processing company in the world turned over and started making that stuff. I don't care whether you're talking South Africa or Europe or the United States, right here in Boston. So everywhere. And then with the materials, all the problems of how you process it this way. How do you take a bar of steel that you used to machine and turn it into powder and turn it back into a piece of steel that has the same kind of properties that bar had? How do you take human cells and get them to grow together and become a human organ? Absolutely amazing. How do you handle that material? How do you dispense them? And then how do you turn them from a liquid or a powder back into a solid? What in process as you move, you're trying to push this stuff out, and you get to cure it as you dispense it or as you run it through the process. So whether it's UV light or hot irons or lasers, electron beam, and one of the key difficulties is getting them to have the kind of properties that you want to have in your finished good. Next slide. This is just one we did not look at before, I do not think, but the electron beam is being very actively utilized in metal work rather than lasers. But it has to be done in a vacuum environment. So the printer that you use has to actually be in a vacuum chamber. Next item. Uh, the only item here is this 3D printing is 2D printing on top of 2D printing on top of 2D printing. Now, how do you get the material to bond to each other as you go through that? We'll see one in building concrete housing. How do you get that, or in many other areas, but how do you get those various layers to actually bond to each other? Because what you're really trying to do, for example, in metal, what you're really trying to do is weld two rings together. How do you do that? Next. Let's take a look. Well,
This is the one I couldn't find for you, George.
okay. This really is it's a soft video about the new software, and in this video, you decide you want to buy a certain kind of product. So you can go on the internet and find the software that makes that product, or you can have the software yourself and you can create it, the CAD system, and design it, or you some way you decide what you want, and you send this off to one of these 3D manufacturing companies, and within minutes, you have a quotation for how much it will cost to make that product out of the material that you've selected from a whole list of items, whether it's plastics or metals or whatever it is. And if you want to change the quantity, you can have one piece or 10 pieces or 100 pieces, and you get a price for the lot. You get, the vendor will come back with recommendations for modification of the design for lower cost or lighter weight, less material, or whatever. And it happens, it's like going on Google and wanting to know how to get to the next town. It's almost, not almost instantaneous. It's amazing how they handle the whole network. Next. This is just this is a file. If we went in and did this, we're not going to, but if we went in to this website, you would have an entire listing of all these materials. It will give you what temperatures they take, all the information you need to pick a material out of all of these for what you want to have done your product made from. And just go in and pick it, and it gives you the specifications for the materials. And you have materials that combine titanium with stainless or aluminum. The powder is mixed so that you have a type of material that you can't buy in bar stock. Next. This is just, there's one of these today in every dentist's office. The dentist I have has one that looks like the one on the left. I go in and he makes a tooth. Now, my company made, I think, the first dental, but it was not printed. We made one for the dental department at the medical department at NYU in Manhattan, and we ground a piece of plastic. The machine actually ground the tooth from a piece of plastic, but it was about the size of that one, and it sat in a dentist's office. Now they're printing them. My dentist takes a picture of my tooth, X-ray, and makes a cap, puts it on. So, and you know, he has no special skills. He hasn't been to trade school to learn how to run a machine. So that's where they're at today. Next. In the medical field, which is a major operation, they were first used and are mostly used, even today, as models to rehearse for operations. Heart surgery, they print out a heart and produce it, and then they practice on it before they go and use it, before they go and do the actual operation. The prosthesis is a very active area. Even up here at the University of Lowell, they are making prosthesis up there at the university, and they have a program where they're working with this general area, making prosthesis, and students are running the program. Joints, my daughter has one of those knees. They reproduced her knee, 3D printed it, and she's running around like nothing at all. They're doing heart valves. They haven't figured out how to do hearts yet. It's far as I know, with their own heart valves. And they're doing their job. One of the things I want to get into with some depth, I'm hoping we're going to see the videos on this. But one of the things that's happening in medical is that they're doing a lot of work with organs. They're also doing a lot of work with artificial skin, treating burns, that sort of thing. And to do it, they have to combine cells. And is Jerry Slate on board?
He was here this morning, George.
I'm here.
Oh, yeah.
I'm still here.
Okay, don't go away, because you know all the words and you know what's going on here, and I'm just a rank amateur on this stuff. But so join in if you want to help me out along here anywhere. But when we 3D print, we can print like a trellis, but the skin that's on it, we can't hold in place, and it grows. So you saw earlier where they had a steel joint for the hip, full of holes for the bone to grow into. And what they are doing is they build a framework, and then they have your cells in some kind of a carrier. They spray that on in some fashion, and then they have found that over a 2-week period that the carrier disappears and the cells are growing together and become a skin. So that is the method, fundamentally, that they need. So they have to be able to put a liquid on it. And there are several pieces of equipment that we're going to see here in a second, in which they are spraying the cells from 2 different nozzles, and they combine in the air as they're being applied to the surface. So let's take a look at those. Right, yeah, there's one. And that's a stem cell, says printer. But what's happening is you can see that's handheld. That's, that's not a, that's not a 3D, that's not a 3D printer, but they call it a printer. And then go to the next one. And that's a same thing, but a different design. And you've got your 2 liquids coming from 2 different directions, but they're meeting in air before they are applied to the surface.
Can I make a comment about cell biology here they're taking advantage of?
Yes, absolutely.
If you have a cut on your arm, like a knife cut, and you oppose the edges, say with sutures or bandage, then it just heals together. That's called primary intention. If you have an open wound where the epithelial cells are not touching anything, they are genetically programmed to continue to grow until they find an edge and then fuse the edge. So in the printing business, I think what they're doing is they're exploiting the genetic tendency towards secondary intention for the cells to join and fuse together as a single layer of skin, because that's what our skin does. That's all I wanted to say about that.
And when you get to trying to create organs, you have no choice but to do it that way. Is that correct?
Right, but it will do it because the cells are genetically programmed to do that. They are genetically, maybe use gravity, they use position, and they fuse together just as the way they do in development.
Right. Okay. This is a handheld printer that's designed up in Canada. And you can see they're laying down a thin layer of, and this is, they're using it in the burn clinic to cover skin in a burn situation. Next. We get into human organs. And this is, to me, I find it amazing. And it's, they are making progress. As I say, they have heart valves, but I don't know of any human heart or human liver that has been installed. They have done those in animals, they tell me, but the construction that we've been discussing, the difficulty of it, is what they're trying to overcome and seem to be making progress, Jerry. Next. Let's see. All right. Well, I'm to the best of my knowledge, this is what I've been saying. The matrix can be 3D printed, and but the stem cells cannot. They can be dispensed, but they can't be put into a path. They follow their own course, and they say that they can do it. They can use your stem cells if you're under the age of 50. They need a bioreactor to culture them, and then the bioprinting is not like printing otherwise. It's really dispensing, in my view. Next. This is just the contrast. What you're looking at on the left is a natural human liver. And on the right is liver tissue that's been bioprinted. So it's part of the research that they're doing to be able to print the liver. Now they can create it in the lab, and they can use it as flesh, if you will, for testing and that sort of thing. But getting it from that position into a working liver is what they're still working on. And they have them, as I say, for animals, but as far as I can find out, not for humans. Next. All right. They've made mini livers. And this is the equipment. This is just the machine that they use to do that. And that is a printing machine. So,
You see the name Incredible?
yeah. I gotta tell you that they've said, that they've got more work to go to get a complete organ. They've got an incomplete organ so far. I'm gonna bypass. We've got a not a video, but we've got a print for this. But I'm gonna bypass it. Let's move on. All right. Now, one of the things they're doing is they're doing printing in space. And what they're learning is advancing their ability to create organs, human organs. But part of that is because they're in an environment where gravity is not distorting the shape of the organ that they're trying to produce. So the space station is now has a printer and is doing this research in the station. And they're learning a great deal. Again, I'm not a doctor, so I can't get into the details of that. But that's what's happening. Next.
Hang on.
There's your space station. Next. While we're up in space, those are magnets that were rare earth magnets produced in the space station in the same program as the medical work. And it has the same, some of the same issues in terms of forming the rare earth magnets. Next. In metal, and I don't have a video of this specific thing, there's a very brief shot, but the Orbit's rocket engine is being entirely made by 3D printing. And this is metal. It's a rocket engine. And what I'll touch on a little later is that you can get yourself a 3D printer, metal printer, and you can go on the internet and you can get all the software and you can build yourself a rocket engine in the backyard. So that is fairly advanced. Let's take, I think this is the one we're going to look at. Yeah. Let's look at this first one.
I was just asking if these are videos from people who are trying to get us to invest.
I don't, I have enough trouble finding the ones that are, I think, germane. I don't pay any attention to who's promoting it. Almost everything that's available is being done by someone who has a interest in the industry. They're making materials, or they're making the machinery, or they're selling the service. Yeah, let's move on. Let's take a look at this one. The one at the bottom. But I was questioned by some members about whether we were printing shoes. So I wanted to just show this one. There you are in front of you. There's the first one. And take it down. I think there's two more like that. Just the picture. That's a printed, looks more like a slipper. There's a better shot of it. That's 3D printed. Doesn't look it. I wear, does anybody wear these Skechers? And that's what they are. That's it. That's all we need to show. There is a company out in the Worcester area that makes the soles for footwear produced all over the world. They ship them from Marlboro to everywhere, and they're just the sole. And then in Germany, Adidas is producing the insole, and that is 3D printed. That's such an insole. So, and the Skechers appear to be the same way, but they have no insole. The insole and the outsole are the same. So that looks to me like a 3D printed sole, not necessarily a whole shoe. And I was aghast when I found out that they're producing soles out here in the Worcester area and shipping them all over the world, where people then put the uppers onto the soles. So there is a distinct change coming on in the footwear industry, and both in the design of the shoe and in the dynamics as to where they are produced. And this is indicative of what I'll talk some more about here in a second. But this is happening everywhere. You can now buy yourself a machine and pick up the software and produce footwear, put the same footwear, produce it in South Africa, Asia, Alaska, anywhere you want to go. And so, anyway, there's your shoes being 3D printed. Let's move on.
But George, using that graph that you showed 20 minutes ago, it would seem that shoe soles are something that you make lots of and therefore don't seem to be cost effective.
That is absolutely correct. But what's happening is that let's take the footwear. When you make a sneaker, as we used to do in Watertown, and I'm familiar with that plant, there are hundreds of little pieces that have to get made and assembled. And when you order 100 pair of size 7, you've got 30 different pieces of that size, and you got a different set of pieces for the size 11 and a different set for the size 12, and it's a bloody nightmare. If I can take a machine and do the whole damn thing on one machine with maybe 2 materials, life is a hell of a lot simpler. So there are savings on the other side, and a great deal of what's going on with 3D or additive manufacturing is that you can produce something you could not produce. You can do it in smaller batches. You can do it in geographic locations so that you don't have to ship stuff. Imagine what it's costing to ship the damn sole from Worcester to South America to be made into a pair of shoes that are delivered to Germany. Crazy. So there are savings in a different fashion. I think that's all I can answer on that. Plus a lot of
Still hard
George,
to believe.
thinking about what you're saying, if assuming you put a 3D printer or a school of them, if you will, into an Amazon warehouse, your order comes in, it goes to the 3D printer, and you get your product the next day or whatever it takes to cool it and manufacture it.
that could happen.
Scary.
Not only that, not only that, although I think George, to some extent, touched on this, you cut down on the amount of inventory you have to have, including parts that you're going to have to put together by anticipating the particular sizes of shoes and things like that. So
Lots of implications. You're exactly right.
And you have the possibility of having these things really be custom made, so they might even be comfortable.
What a concept.
In
Sure enough.
1939, J.C. Penney was the largest footwear account in the world. Their footwear was produced at the B.F. Goodrich Hood Rubber Company plant in Watertown, Massachusetts. My father was the guy in charge of all that scheduling and distribution and production. And 20 years later, I was working for Goodrich, and I was in charge of automating the manufacture of it and moving it out of Watertown to the Carolinas. So I could spend the rest of the day talking to you about this one. But it's interesting to see what 3D printing or additive manufacturing is doing. So let's real fast. I could show you this. I'm not going to because we're getting short on time, and I'd like to show you a different one. But the industry all over the world turned to with COVID-19 and started producing ventilators. I could show you some longer videos of this, but MIT, they came up with a little machine to be able to go and take the bag that's hand squeezed, just a little machine to squeeze the bag. So you took a hand ventilator and turned it into an automated ventilator. Ford Motor, as you probably have read, it turned into manufacturing this, and it has nothing to do with 3D, except to say that the father, the engineer at Ford that turned that Ford plant into a ventilator producing plant, father happens to work with me here in the Massachusetts area. But the 3D printing industry all over the world is today producing ventilators, masks, shields for the industry, and they turned on virtually dime. One person, they went to open source software, and everybody in the world picked up on it and is producing it as we speak. Next, I'm gonna part on this one, but let's watch this. There's all kinds of stuff going on, and it's going on everywhere. We're past our time. Can I talk for another few minutes?
Sure, if people get bored, they can always leave the meeting.
Exactly.
Well, I won't follow the what I want to tell you is that the global impact of this, everybody is getting excited about this whole process of additive manufacturing. Every damn university, I think, has their PhD candidates using the younger students to work on these projects that you're seeing, from MIT to which has a big department on it and runs a pretty big course on it, to the universities in China and Australia and South Africa. Everybody's doing it, and they're finding all kinds of new applications. It's research that turns into production. It's problems that get solved. University of Lowell doing it all over the place, and it allows every country to have their own manufacturing facility. 1960, I was starting manufacturing in all, 33 countries around the world. Bolivia, Peru, Brazil, everywhere except Africa and Russia. I've worked on a plant in Iran, 1958. And these projects and this process is going to grow in all these places. You saw those housing, that's in Saudi Arabia, in the Middle East area. Opportunities that we don't even think of yet. So that's going to happen. And you're going to see this spare parts on demand. You're going to find, and one of the things I worry about is the bad side. And piracy of both knowledge, because this is it's full of patents. Everybody's got a damn patent on something. So there's going to be all kinds of shenanigans there. But piracy in a sense of bad with terrorists, realize that a terrorist now can order himself a 3D printer and can make a damned rocket. And he has on the internet, he has all the knowledge he needs to fire that rocket from the Mideast into Palestine, from disturbed territory in Afghanistan, or out in Kansas or wherever. The do-it-yourself gang can cause all kinds of trouble. So when you can build a rocket now in your backyard, expect some bad things to happen as well as some good things. And the chart ahead of you is 4D. That reversible energy absorption and shape changing, and that lattice-based structures. There's all kinds of applications there. Think of printing a circular, like a latticed stocking, if you will, that you pull over your arm, you soak it in water, pull it over your arm, and when it dries out, it's a splint. The 4D is that the material itself changes shape. So there's all kinds of applications where that happens. And it happens just by temperature change, by moisture change, but it's just another set of the application.